And this is 10 inches. So how can we set this up? What is the part we control?
How much you cut?
How much you cut? So how should I label this? So I need a variable, right? So probably the easiest one is put an X here. And then if you do that, this side is X, all these are linked X, and then what would this length be? 10 minus 2X. And then same here, if that's length X, this is 10 minus 2X. So I have this, and I use it to build my box. In the directions, it says it's an open top box, because what's missing? When you boil this up, you don't actually have a top to the box. The way we did this. So always be careful in the directions. It'll say open top, closed top, things like that. You want to make sure you pick up on that so you get the right coordinates, or not coordinates, right geometry. All right, so if I want to maximize volume, what is my volume? So length times base times height. So width times base times height. So what would that be based on this picture?
So that's perfectly cube. So wouldn't it just be like
Well, the way I drew it, it doesn't have to be a cube.
Well, yeah, I just meant for this specific example because I can't quite tell if that's supposed to be like slightly rectangular or an actual cube.
The height so the base is square, but the height's X, right?
Okay.
So when I hold this up, what's the height? X. Then what's the base here? 10 minus 2X.
Oh.
What's out this side? 10 minus 2X. Right? When you flip this up, this becomes a side. What would be the height of this? It would be this X length. But then for the base, that's this inside square. So I know it's 10 minus 2X, 10 minus 2X. Does that make sense? Okay, all right, so for this problem, my volume is actually what? X times 10 minus 2X squared. And then what is my domain, or feasible domain? I want to make a box. What do I need? What's the smallest value for X?
0.
0. Like I need to make a cut to make a box. So I know X is bigger than 0. How big can X be? Why?
Well, we could cut the entire thing, cut the entire piece of paper into 4 corners that make the entire rectangle.
So the precise, yes. Kind of the precise way to say that, this 10 minus 2X has to be a positive number, right? If I'm going to have a box, 10 minus 2X must be bigger than 0. So 10 must be bigger than 2X. So X must be less than 5. And really what it's saying is if I cut past 5, I can't cut up here and down here and remove 2 things. Like the barrier is cut in the middle and cut it to the fourths. Okay. So I have this. X is between 0 and 5, and my volume is given by this. a lot of test, or I shouldn't say a lot of test problems. There will be test problems that say come up with the objective function and a feasible domain. That's what we have here, right? My objective is to maximize this function capital B, and my feasible domain is x is between 0 and 5. So there are problems where we let you stop here. Right? There's always two parts to this section. First part is, can you get the setup correct? And then once you have the setup, okay, here's a function, can you find its absolute maximum on this interval? But then that's kind of like the first part of the section, right? All right, so how do we do this problem? What would be the easiest way? So this is the setup. How do you find the absolute max? Yeah.
You need to find the critical numbers, which means you need the derivative.
Yeah, you need to find critical numbers, then once you have the critical numbers, take the maximum is going to be the correct number of endpoint. So my volume is, I'm going to expand this to make it a little easier. So what's that, 100 minus 40x plus 4x squared? So 100x minus 40x squared plus 4x cubed. So my derivative is 100 minus 80x plus 12x squared. Now what?
You still have to find the critical numbers.
Yeah, so I need to factor this. Or what else can I do? So if I set this equal to 0, I'd get what? X is upside down. I have to factor this, use my Pythagorean theorem. This is quadratic. So if I set that equal to 0, I get what? 80 plus minus square root of negative 80 squared minus 4 times 100 times 12. All divided by 2a. So 2 times 12. Right up that is. You'd think I would. Here's the nice thing, on a test, everything will work out nicely. Alright, so 80 plus square root. So 80 times 80 minus 400 times 12 divided by 2 times 12. Seems like a lot of work to get 5. So I get 5, and if I do the minus sign, which means all this probably factored nicely, and I was too lazy to try to factor it. Oh, no, otherwise 5/30. Who knew quadratic formula would show up in every problem of your life? Alright, so I set this equals 0. I get two numbers that matter, 5 and 5/3. Now what? Yeah. I find the limit as x goes to 0 from the right of my function. Find the limit as x goes to 5 from the left. Why am I doing limits? Can I set it up as an open interval? If it's an open interval, can I just plug in 0 over 5? And then the last one would be find b of 5/3. Do I need b of 5? Technically 5 is a correct number.
Well, but you can't reach 5 actually.
Yeah, I don't actually reach 5, so that's
But-
irrelevant. Yes.
Couldn't you also have made your life easier by factoring out a 4 from the derivative? Like just 4 by itself, so that way you have smaller numbers to use in
That
the...
would've been smarter, yeah. I'm embracing the fact we have calculators the first time in this class. But, yeah, I could have factored a 4 out here. And then just need this for quadratic formula. Alright, so what do I get? That take this one as I go to 0. Volume would be 0. What about when I plug in 5? Should be 10 minus 10, so I'd get 0. And then what's b of 5/3? That would give me 5/3 times, it's always easier, usually plugging back and forth. 10 minus 2 times 5/3 squared. So 5/3 times, what's that? 10 minus 10 over 3? So what is 10 minus 10/3?
20/3.
Yep. How do you do that? 30 minus 10, so 20 over 3. Alright, what do we know about that number that's relevant for this problem?
It's greater than 0.
It's greater than 0. What was my goal? My goal is to find the maximum. So I need the biggest value. Biggest value happens next. Right? So what should I do? I should let x equal 5/3 of an inch. If I let x equal this, I guarantee I get the maximum value. The last step is always go back to your question and see what it asks for. Sometimes it'll say, how big should the cut be? The cut should be 5/3 of an inch. Or it'll say, what is the maximum volume? The maximum volume would be this number. Alright, so you do want to go back to your problem. Make sure you're answering the exact problem asked. Sometimes you want the x value, sometimes you want it like a y coordinate. Just make sure you're answering what's asked. Any questions on that one? It is important to always justify it's a maximum or a minimum. So like, don't just find the correct number and say, hey, only 5/3 lane my interval, surely that's the right answer. It could be an endpoint. This one, it wasn't going to be an endpoint, but there are problems like that swimming and running problem, or rowing and then running. Depending on what links we give you, that could be an endpoint or a critical number. So there are problems where the max or min is at an endpoint still. That can still happen even in this case. That's part of the feasible domain coming in. All right. Yes.
Well, because that wouldn't make much sense for like a problem with like the specific where it's asking for volume. Because if you have one from at the end point,
0, that makes no sense.
Yeah, so
that's where it's context driven. There are problems where it's an endpoint. There are problems where definitely endpoints make absolutely no sense. And every problem is semi-unique from that point of view. This is one we won't do. This is always a fun one. Do you watch Friends? Anybody? It says a beam, but we'll say couch. Let's say you're trying to turn a corner in a hallway. What's the longest couch you can carry and turn the corner? So if you know you have an 8-foot hallway and a 6-foot hallway, there is a maximum length. Of course, it doesn't let you pivot. The way this is set up, it's in 2 dimensions. If you want a longer one, make sure you pivot so that it's a little bit shorter. But this one's fun. If you actually solve this, so it says what's the longest item that can be carried around the corner. We always say make sure it's a max or min. So for this one, you expect to get a maximum, right? If you set it up the most natural way, and you check, your answer is actually a minimum. It takes a while to figure out why. The reason it shows up as a minimum is you end up finding the shortest length that doesn't fit. Or sorry, the shortest one that does fit. Or sorry, yeah, shortest one that doesn't fit. So if you actually solve this, you don't get a maximum, you get a minimum because it's the smallest length that will not turn the corner. Anything longer than that would not turn the corner also. So it's one of those, you always need to check your math and check to make sure the context makes sense when you get your answer. Okay. We used to do this section for like 4 or 5 days, in which case we did lots of examples. Kind of like the other one that you always hear about, what if you have two planes flying by, how close do they get? They fly over a city. And all these awful problems you always hear about in cartoons or anything, like Simpsons where they make fun of math. Those are the standard problems we do. Alright, I was gonna maybe do this one. Let's say we wanna build a container, and this is a typical setup where it costs more to build is this one the base or the top? Yeah, it costs more to build the top or bottom than it does to build the sides. Alright, so like sometimes you have to reinforce the bottom or reinforce the lid. That part can cost more than just building the side part. So let's say you're building some container. Set it over here. Alright, so we want it to have a volume of 6 cubic feet. And let's see, the walls cost $1.50 per square foot. And the top and bottom are $2 per square foot. All right, and the goal is to minimize cost. All right, so how can we do that? All right, so we have our cylinder. How am I going to do this? I always start with, what do I need to get the cost? Yeah.
You need the surface area of the cylinder as a whole minus the two circles. And then multiply that by 1.5. Then you multiply the surface area of the two circles by 2.
Yeah, so this is really what you're saying, right? Add together the cost of the top, cost of the bottom, cost of the sides. What's the cost of the top?
Oh.
What makes this hard? What have I not done yet that you really need?
We don't know. Wait.
I just have a random picture of a cylinder drawn. What am I missing to write what formulas are? How do you get the area of the top? Because it'd be the area times the cost, right? So that's the area of a circle? What's the area of a circle?
Yeah.
Sine times the radius squared. What's my radius?
Wait.
So I haven't labeled anything. I definitely need a radius, right? So what's the cost of the top? Pi r squared is the area times the times $2.
Wouldn't the two circles be the same area? So couldn't we technically multiply that by 2?
I broke it apart because sometimes it'll say the bottom costs even more than the top. Or it might be open top, in which case you only need the cost of the bottom. So this one ends up being the same, right? Area of the bottom is pi r squared times $2. How do I get the cost of the sides?
Find the circumference of the circle and multiply it by the height of the cylinder.
Yep.
So what do I need? I need to know the height. So that would be height. What would this length be? You already said it once. Circumference of the circle. So what is that? 2 pi r?
Wouldn't we?
If you take your cylinder and unroll it, what's the length of that? It would be the circumference here. So if this side is length h, think of this as a rectangle when you unroll it. How long is this? 2 pi r. So this would be 2 pi r times h to get the area times 1.5. Is that believable now? I could have given you a diameter, I didn't have to do radius. Like this is where you make sure you label your picture and then everything is based on how you label. Right. I didn't use XY, I used RH. Doesn't matter, just make sure you're consistent with labeling. Alright, so this is my cost. What's the problem with this? Can I take a derivative and find proof numbers? So both R and H can change, right? I can choose anything I want for H and then something else for R, or I can choose anything I want for R and then something else for H. What is the one constraint that I have?
Volume is equal to 6.
Volume has to be 6 feet cubed. That is my constraint. So what is going to be the purpose of this constraint? It'll let me get rid of an R or an H here. So what does my constraint say? My volume is equal to 6 feet cubed. So what does that tell me? 6 is equal to what? How do you get the volume of a cylinder? Base times height. Area of the base times the height. Alright, so y'all are hoping for a cylinder tomorrow, right? That's what I'm getting out of this very confident discussion on y'all's end.
I hate to be that guy, but isn't it supposed to be cubed?
Yes. That's why you get 4.5 out of 5. When y'all submit things, when you make a typo. That's what that half point is for. It's not perfect. You can't say it's perfect. Area of the base times the height. What's the area of the base? Be the area of the circle, right? The area of the circle is pi r squared times h. Now what?
Now you can solve for one of the variables in terms of the other.
Yeah. Which one's easier to solve for?
H.
H. Alright, I guess we'll solve for H. H is equal to 6 divided by pi r squared. So now I need to plug that in, right? So this is going to be 3 times pi r, and now H is 6 over pi r squared. Plus 4 times pi r squared. So what do I end up with? It's going to be 18. Pi divided by pi goes away. 18 over r plus 4 pi r squared. So my cost as a function of r is this. Yeah.
Can we rewrite the 18 over r as 18 times r to the negative 1 to make it easier to take the derivative?
Yeah. Alright. Everybody believe that's the cost? Everybody understand where it came from? I did a little bit of simplification. I guess I'll top my head. What am I missing if I want to make this find the absolute max or min? We have a
The endpoints.
The interval. What is my feasible domain? This one's a little different. Before, we can always come up with good numbers. What do I know? I know the radius has to be positive, right?
Mm-hmm.
Is there an upper bound for my radius?
Infinity?
Yeah, because you could have a radius of infinity and it could still have a volume of like 0, right?
Granted, that wouldn't be very logical, but it's possible.
Yeah, what happens here? 6 is equal to this. When the radius goes to 0, this must go to infinity, right? What happens if I send h to 0? Then my radius must go to infinity? Can I still build something with a volume of, like, no matter what I choose for r, there is a value for h, right? And it's positive. Like, my real constraints are I need r greater than 0 and h greater than 0. And however I choose them, this needs to be 6. Is that always possible? If I give you any value for r that's a positive number, there's always a value for h, right? So is there an upper bound? If I pick 1,000,000, I can find h. Can I go bigger? I can literally pick any positive number here. And there is an h value that still gives me a volume of 6 cubic feet. So this is the first one where my domain says r can just be any positive number. There is no upper bound that physically doesn't make sense anymore. So what does that mean? I can basically make it as wide as I want, or I can make this as tall and skinny as I want. All of these could have a volume of 6 cubic feet. Alright, so now what? So we have the setup, right? I want to minimize my cost. My cost is given by this function. It only depends on r, and r must be in the interval 0 to infinity. I mean, it's still a feasible domain because in here I could say let r be negative and it would make sense, but I don't have a cylinder. Alright, so what do I need to do now? I need the critical numbers. So if I find the derivative, it's easier to read it like this. So I get negative 18r to the negative 2 plus 8 pi r. So minus 18 over r squared plus 8 pi r. Now what do I probably want to do? I mean, in some sense that's good, but usually like these as a fraction and factored if possible.
Well, couldn't you multiply the second term by r squared over r squared?
So use a common base of r squared. So then what do I end up with? Negative 18 plus 8 pi r cubed divided by r squared. Right. So when is this undefined?
When the bomb equals 0?
Can't divide by 0. So this would be undefined at r equals 0, which in some sense doesn't matter because we said r is positive. But it's always worth checking. And then what about equal to 0? That says the top must be 0, right? So 8 pi r cubed must equal 18. So r cubed is 18 divided by 8 pi. So divide everything by, I guess, 2, right? 9 over 4 pi. So r is the cube root of 9 divided by 4 pi. which is a positive number. So it is a critical number in my domain. Now what do I do?
Load our endpoints and critical values into the original function.
Yeah, now I want to test, right? So I want to know what is the limit as r goes to 0 from the right of my cost. What is the limit as r goes to infinity of my cost? And then what is my cost evaluated at this number, cube root of 9/4 pi. So what happens when r goes to 0?
8.
18 over 0 plus 0, which is what?
Infinity?
Infinity? My radius goes to 0. Basically, I have this infinite height, and that infinite height I still have to make. What about as r goes to infinity? 18 over infinity plus infinity, so 0 plus infinity, I get infinity. Then what about this last one? I have no idea what that number is. I don't know if I plug it in. If I plug it in, I get a number, right? I get just some positive number. Some number bigger than 0. What's the important thing about this number?
It's less than
It's
infinity.
less than infinity. Whatever I plug in there, I'm going to get a number less than infinity. So whatever that number is, that is the minimum cost. So the question was, what dimension should I make it? I need to make sure my radius is this value. And then what do I do for the height? So I know my radius should be whatever I just found, cube root of 9/4 pi inches. And then my height should be, I go back to here, 6 divided by pi times r squared. So this number is 3/2. Oh, that's cube root, sorry, 2/3. Right? Then it's the calculator's I can find the radius and the height. It's guaranteed to minimize because it's the only critical number. The endpoints were awful choices. Critical number must be the minimum. It's the smallest value. Hardest thing is always drawing a picture, labeling it correctly, and just getting the right formulas. And some of these, the numbers aren't going to work out nicely, and that's unfortunate. But on the exams or quizzes, they will always work out nicely. You can still have a calculator, but the numbers will at least work out doably. Or you'll say set up and don't solve, which is a hint. Set up and don't solve means definitely don't waste your time doing all this because it may not work out nicely and you can spend a lot of time doing it. I won't give you that much room. Definitely set up only. Any questions on that one?
So the cutoff point for the words for the setup and don't solve, is it like
Getting to here,
So once you get to the
which included the blue constraint. That's actually how I switched colors to it. You know, it's fine.
so everything in blue.
Yeah. It's like you would need a picture that's labeled so these variables have meaning and some way to relate that to the cost. And then what my feasible domain is. Which feasible domain is basically always, you have this constraint. What does the constraint tell you about your variables? There are some problems where you don't always have a constraint, or it's not obvious what it would be. That's where we always ask for this part with the feasible domain. And what I'm thinking of is like the rowing and then swimming. We know that domain without ever introducing a constraint. If you think about that one, it said you either go straight to shore, so distance 0, or you row the whole way, distance, whatever that distance is. My domain is going to be somewhere in between there. Like there's no constraint equation that you didn't have to solve and eliminate variables or anything else. But that's where we look at your picture and see what you have. All right. Anything else? Yes.
Number 33 on the homework.
Number 30 in the homework?
No, 33.
33? Let's see what that is. Oh, that one's awful. Oh wait, no, 33. Yeah, that one's worth it. Alright, number 33. F of x equals x squared minus 2x is 1. And the point is 1, 2. And I want to minimize the distance from the graph of x to this point. Alright, so that's really just, right? X minus 1 squared. This is one where just what the question is asking is usually the biggest point. And then get set up. So here is the graph of x minus 1 squared. And it gives us the point 1, 2. And the question is, what is the minimum distance between this graph and the point? So, think about that. I could move straight down here. What's this distance? 2 units? Or I could pick some point up here, and I get some distance. Or I can move this way and I get some distance. Is it obvious what's the shortest? This looks like it's a little bit less than 2, right? And then this is definitely bigger than 2. So then where should I be? What x value over here would give me the smallest distance? So how do we set this up? Yes.
This is the form of a triangle.
I have a website for this. So like you could move this point around and there is some distance. So like down here, we said it was distance 2, that one was easy to see, so you can see the 2 here. And then as you move it, the distance is getting smaller. So there's a 1.3. Looks like it's around 1.32. And it starts getting bigger. And when you go up here, it's definitely bigger. So it looks like this minimal distance is around 1.32. Happens somewhere around here. All right. Now we want to actually find it. Nice thing is these are so classical that there's almost always a website that already has this. So you mentioned we need Pythagorean theorem, or another way to say it is we need the distance formula. What is the distance between 2 points?
Square root of the difference between
So if I wanted the distance between 2 points, I would do this. So our goal is to minimize distance. And what we actually do is instead we minimize distance squared. Why would we do that? Are we allowed to randomly do that? Not the smallest distance, that's also the smallest distance squared. Why would I do that?
To get rid of the square
Get rid of the
root.
square root, I don't need chain rule for all that stuff. So it makes all the derivatives, everything else easier. So actually when we set this up, we don't minimize the distance, we do the distance squared. It's equivalent, but it makes the math a little easier. So what is my distance squared? My distance squared would be change in y coordinates. What is my change in y coordinates? So I pick a random point here. This is x comma f of x. And I have this point here, which is 1 comma 2. So what is the distance? Change in y coordinate would be f of x minus 2. Plus, what's my change in x coordinates? X minus 1. So my distance squared is what? X squared minus 2x plus 1 minus 2 all squared plus x minus 1 squared. So x squared minus 2x minus 1 squared plus x minus 1 squared. That's my domain. So I want to minimize this function. What do I mean by that? I want to minimize that function. So if I want to take derivatives and all that, I'd probably expand that, make it just a big polynomial. A little easier to work with. What else? What's my restriction on x?
any value that's defined on that.
F of x makes sense for all x values, right?
Mm-hmm.
So I could pick any point for x. How many answers am I going to get? 2. There will be 2 x coordinates that work. Because whatever this one is the same as this distance. But then so, I can't remember how the question is. If it says what is the minimum distance, that's one answer, right? But it might happen with 2 different numbers. There will be 2 critical numbers that make sense. Does that make? So there will be one answer for minimum distance. And technically we're doing distance squared. Doesn't matter either way. And it'll happen at 2 x values. So when you find the critical numbers, you should get at least 2 values. What's the distance when I go to plus or minus infinity? Infinity. So we know it's going to happen at the critical number. My endpoints definitely give me a maximum distance of infinity as the jump choice. Endpoints are almost always dumb choices except for the one problem in the homework where they're not. I shouldn't say one, I don't know how many, but there are homework problems. I should rephrase this. There are problems in that section in the list of problems where the maximum or minimum is at endpoint. I can't remember if those are assigned or not. But I know there are some where that happens. All right, any questions? Always draw pictures.
So if we have all this worked out on the homework, can we kind of just justify not to the plug-in for the limits or for?
I mean, you always want to justify, is this a max or min? The easiest way to justify it is
Do the
plug the endpoints.
Yeah.
The other one is you can do a second derivative test if it's a nice enough problem, like if it's always concave down, and we know it's always concave down, this must be a maximum. If it's always concave up. So when do we do that? If the second derivative is like a constant. Now you know you either have this shape or this shape because we did curve sketching. So there are other justifications. You could do a first derivative test where you draw a number line and like something that is increasing and decreasing. Say decreasing and increasing. If it's only this shape, you know this is a minimum. And you know the maximum is going to be at the endpoint. One or the other. So there are ways to justify it using lots of tools. In class I keep using this one. I think in the videos they do first or second derivative test. So there are multiple ways.